have a look at them here. Where would you like to start?
Either one's fine.
Number one?
Sure.
Okay. For some reason my screen is not... What's going on here? Hold on a minute. This doesn't seem to start at number 1. It seems to start at 11. Am I on the wrong one?
There's one there's like a couple before it.
Let me look at the other page here. Yeah, this is number 1. Okay. Here, let me snap that left, snap that right. All right. Let me blow that up a little bit. All right, let's start with number 1. Angle 13 and angle 2 are what?
Alternate exterior.
Good. 16 and 11.
Alternate interior? No. Vertical.
Yeah, vertical. In other words, whenever you have two lines that cross, you form vertical angles. In other words, hold on. If I have that situation there, then angle 1 is equal to angle 2. Those are vertical angles. And angle 3 is equal to angle 4. So whenever you have two lines that cross, regardless, even if they cross like that, you have vertical angles. About 6 and 10.
Corresponding? No. Consecutive interior.
Well, let's talk about this for a second. They make this subject a lot harder than they need to. If I have two parallel lines and a transversal, I create 8 angles, right? 1, 2, 3, 4, 5, 6, 7, 8. But notice that there are only 2 unique angles. There's an acute angle and there's an obtuse angle. And every other one of these is either the acute angle or the obtuse angle. So 7. Is 7 equal to 1 or 2?
2.
Yeah, and we don't have to know anything else other than we can see that 7 is acute, 2 is acute. What other angles are equal to 1?
5, 8, and 4.
Correct. And 1 and 5 are corresponding angles. That's what's corresponding. Okay, and 1 and 8 are alternate exterior. So it is, for your geometry class, it's important that you know the names of these, alternate interior, alternate exterior, but that's not what's really important. What's really important is that you understand parallel lines with a transversal. And you only create 2 angles, and 1 and 2 are supplementary, always, which means that 1 and 6 are supplementary. You see why? 1's obtuse, 6 is acute. They have to be supplementary. The acute and the obtuse angle are always supplementary when you have parallel lines.
Okay.
Okay. So how about 7 and 3?
They are corresponding.
Nope. Whenever you have a straight line and another line
Oh,
that intersects with that,
supplementary.
linear pair. Do you see how
Okay.
7 and 3 are a linear pair?
Mm-hmm.
Yeah, which means they're also supplementary. So actually, either answer works, supplementary or linear pair, and they don't restrict you using, multiple answers for multiple questions. So 7 and 3 are a linear, and they're also supplementary.
Okay. So
About,
it could be either or.
yes. Notice also that 7 and 8 are a linear pair, and they're also supplementary. In other words, any two angles that are a linear pair are also supplementary. Those two things mean the same thing.
Okay.
Okay. How about 10 and 5?
Alternate interior.
Good. How about 6 and 15?
None of these.
What do you notice about 6? Is it obtuse or acute?
Oh, it's obtuse, and 15's acute.
Which means 6 and 15 are what?
Supplementary or linear.
Yes. In other words, whenever you have a system of parallel lines like this, I not only have this line parallel to the, in other words, the horizontal lines are parallel and the slanted lines are parallel. That means that there are only two angles that are unique in this picture. And that one is the obtuse angle, two is the acute angle, and every acute angle you see in this picture is the same as 2. And every obtuse angle you see in this picture is the same as 1. That's what
Okay.
you really have to remember. I mean, I know they give you all this alternate interior, alternate exterior, but take it from me, you won't need to know any of that a year from now, ever again. What you will need to know is parallel lines and the fact that parallel lines create an obtuse and an acute angle. Now, occasionally they will try to mix you up and they'll give you parallel lines and they'll give you something that looks like it's perpendicular. But they don't tell you that it's perpendicular. So in reality, 1 could be 91 degrees and 2 could be like 89 degrees. So they don't have to be perpendicular. And when we first look at this picture, we can't really tell what's the acute angle and what's the obtuse angle, right?
Mm-hmm.
So this is when it helps to know all these things. In other words, is 3 the same as 6 and why?
Yes,
Why?
because it's alternate interior.
Correct. How about 1 and 8?
Yes, because it's alternate exterior.
Yeah, so when you get to situations like this where you have parallel lines and a transversal that's almost perpendicular and you can't really tell whether these are acute or obtuse, then you have to know this stuff. Then it's very helpful. Tell me two corresponding angles in my picture.
2 and 6 and 1 and 5.
Good. How about give me two consecutive interior angles?
4 and 6 and 3 and 5.
Good. All right. Back to the problems. Let's see. What's 1 and 3?
Congruent.
Yep. How about 4 and 13? In other words, they didn't give us any problems here. They made these lines slanted enough that we can immediately tell which one's acute and which one's obtuse. And it doesn't matter if I'm talking 1 or 16, because all I have to do is tell whether it's acute or obtuse, and I'll know that all obtuse angles are equal to one another in this picture, and all acute angles are equal to one another in this picture. Now, if I had my picture over here on the right, I've drawn it in such a way that I can't really tell what's acute and what's obtuse. So I definitely need this terminology over here to tell what's equal or what's supplementary. And that's really the only two situations. You either have they're equal or they're supplementary. In other words, 1 and 4 are equal, 1 and 2 are supplementary.
Okay.
Okay. Back to your problem. How about 4 and 13?
Are they vertical?
Congruent.
Okay.
Think of congruent as being equal. That's kind of what congruent means. Okay? And I know 13 is equal to 4 because they're both acute. I don't have to do any other work. 13 is equal to 10, it's equal to 5, it's equal to 2, it's equal to 15, it's equal to 12, it's equal to 7, and it's equal to 4. Those are all of the acute angles in this picture.
Okay.
About 9 and 16.
Are those congruent?
Yeah, they're both obtuse. 9 is obtuse, 16 is obtuse, therefore they're congruent.
Okay.
All right. I think I can see enough of this. All right, let's look at this. Shall we go to 10 next?
Sure.
Okay. Angle A. What is angle A equal to? The measurement of angle A.
It would be 57? No.
58.
Yeah.
Let's talk about that. One of the best skills you can possibly have in geometry is the ability to subtract from 180. Okay. Well, I can tell that angle A is a linear pair with that 122-degree angle, right? So these two angles are supplementary. Well, how do I subtract those without a calculator? Well, we can do it the normal way. But notice, these two numbers always add to 17 unless this is a 0. Okay? And that might seem a little strange because what if we had 180 minus 94? Well, whatever my answer is has to add with 9 to be 17. So it has to be 8. This number has to be 8. And this number over here is always the complement of that. In other words, it's 10 minus 4, so that's 86. But notice that when I'm done, these two numbers add to 17. And that's almost always the case. The only time that isn't the case is if I have like 180 minus 70. And then the answer is 110. And notice that those two numbers add to 18. But that's only because that's a 0 and that's a 0 and that's a 0. any other situation where these are not all zeros, these two numbers are going to add to 17. And that might seem like a minor thing, but if we subtract a number like 94, well, I can do it the normal way, but I know that the 9 and whatever number I write here have to add to 17, so that has to be an 8, and this has to be 6. So I can do it in my head almost. I don't really need a calculator to do it. And if you can do these problems without a calculator, you're way better off. And only because you have to do them so often. There's few things in math you're going to have to do more often than subtracting a number from 180. Because not only are linear pairs and supplementary angles add to 180, but the sum of the angles of a triangle. In other words, if I give you a triangle and I say this is 60 and that's 70, what is x? Well, I know that the three of these have to add to 180. So I'm basically 180 minus 130. Now that's 50. And notice those two numbers add to 18. That's because I've got nothing but zeros over here. If I have anything but zeros, then they're going to add to 17. Okay? All right, let's just go through each of these. Are you writing these down so I don't have to?
Mm-hmm.
Okay. What's angle B?
Would that be 58 too?
Also, because B is acute, A is acute. And I see nothing but parallel lines here, which means all the acute angles are equal to one another, all the obtuse angles are equal to one another. What's C?
Is that 58?
Yes, correct. Now what's D? D is basically this model right here. This is D. And over here we have 17 degrees. So what's D?
17.
Based on what?
It is also acute.
Well, yes, that's one thing, but it's alternate interior. In other words, this line's parallel to this line, and D is alternate interior to that. In other words, sometimes you'll have a picture where all of the lines are not parallel. And in this case, that's the case. This line right here is not really parallel to any of the others. But it is a transversal. It is a transversal between this line there and that line there, which means it fits this picture, which means that, yes, you have nothing but acute and obtuse angles in this picture. So that's D, and that's D. And this angle is 180 minus D, as well as that one, and that one. Okay, how about E?
Is that 58 degrees?
Yeah, very good. It's the same as B because it's acute and it's only involved with parallel lines. It has, in other words, this slanted line here is not a part of E. The only thing that E is the two sets of parallel lines. So you can just assume that E is whatever the acute angle is, which we've already figured out to be 58 degrees, that's E. How about F?
122 degrees.
Why?
Because it's vertical with...
That's all you need. It's vertical. It
Okay.
really doesn't have anything to do with the parallel lines. It has more to do with when you have two lines that cross, angle 1 is equal to angle 2. So F is vertical with 122, therefore it's equal to 122. How about G?
163.
Where are you getting that from?
Minus 17 from 180.
Well, G is actually the first tough one we've come across. Okay? Let me draw a little bit of it on my tablet here. There's the line. There's that. And there's that. Okay? And they're asking about angle G. And we know that's 122. We know that's 58. We came up with D already as 17. Well, if this is, and we also came up with that's 122. So there's actually a theorem. You don't really need this theorem, but it exists. And that is that an alternate, or rather an exterior angle is equal to the sum of the two angles that it is not supplementary to. In other words, G is supplementary to X, right?
Mm-hmm.
But both of these angles are also supplementary to X. So therefore, G must be equal to 122 plus 17. 139 is what G is. Okay, now let's not leave this for a minute, because this is a theorem that a lot of people have trouble memorizing, but you don't need to memorize it. In other words, let's figure out what X is. What's X? If this angle is 122, hold on. Now you have a triangle, and you know the sum of the angles of the triangle have to be 180, right?
Mm-hmm.
Well, the sum of these two angles is 139. So X has to be 180 minus 139, which is 41. And if X is 41, well, G is supplementary to X, right?
Mm-hmm.
So it would have to be 139. Well, I can get there quicker by recognizing G as an exterior angle, and the exterior angle is always equal to the sum of the two other angles of the triangle that it's not a linear pair with. So
Okay.
you can actually get there a little bit quicker. And let me just be clearer on this. What we're talking about is this, X. Okay? In other words, X would be equal to 130. It's an exterior angle, and exterior angles are always equal to the sum of the two angles of the triangle that it is not supplementary to. In other words, X and Y are supplementary, but I know that Y has to be 180 minus 130, so y has to be 50, which means x has to be 130, which is the sum of the other two angles. So that's a good one to memorize, is that the exterior angles are always equal to the sum of the other two angles. So let me draw a few pictures here. What's x equal to?
120.
Good. Now what's x equal to?
105.
Yeah, so you're beginning to get an idea of what the exterior angle means. What's x equal to?
100.
Yeah, that's what the exterior angle theorem says. Okay, it's always the angle outside of the triangle at a vertex, and it's always equal to the sum of the other two angles that are not linear to x.
Okay.
Okay. All right, let's see. We did G. How about H? What did we come up with G?
G was 139.
And notice that G is an exterior angle to this triangle.
Mm-hmm.
So G has to equal what? 17 plus
Which was 58.
plus H. Let's start there.
Oh.
And you're right, H is 58. So G is equal to 75.
Okay.
Excuse me, I'm sorry. H is equal to 7. Hold on, let me go back here. I screwed up here.
Yeah,
Just a second.
H is equal 122, I think.
Yeah, this is a true statement. G is equal to 17 plus H. Well, we know G is 139, so 139 equals 17 plus H, which means H equals 122. That's the answer for H.
Mm-hmm.
All right. Perfect. We covered this page. Allie, do you have any questions about this?
Nope.
About parallel lines and transversals. And this is one of the most important parts of geometry. This is so much more important than proofs. In other words, these parallel lines and transversals are something you're going to be tested on for the next 4 years, repeatedly. Where nobody is ever going to ask you to do a 2-column proof again. Okay? So there's some things in geometry that are extremely important to remember forever, and there's others that are not so important. Parallel lines and transversals are big. You haven't taken your SAT or ACT test yet, but when you take them, there will be at least 6 questions on there having to do with parallel lines and transversals. There will be 0 questions on there having to do with proofs.
Good.
Yeah, I know. Everybody feels that way. Everybody hates proofs. I do too, actually. And I don't quite know why they start you off in geometry with proofs. It's just like, what are they trying to do? Demoralize everybody? Um, but parallel lines are a different story. Very, very important subject.
Okay.
Okay? All right, Allie, I will talk to you next week.
Okay.
Okay? Have a good week. Talk to you then.
You too.